Hello, 6th grade math students. This is Chapter 8.2, Writing Linear Equations. We're going to learn to express the relationship between two quantities as a linear equation. And then we're going to use a table or a graph to represent that linear equation. Let's get started. We'll start by writing a linear equation to represent a given situation. Caleb is X years old. His sister is 10 years older than he is. If his sister is Y years old, write an equation that relates their two ages. So from the model, we can see that the expression for Caleb's sister's age is X plus 10. To make an equation using this expression, notice that the problem says that the sister's age is another variable, Y. So we're going to write Y equals X plus 10. The equation Y equals X plus 10 is called a linear equation. We have some vocabulary to learn here too, so let's pause for a moment and learn the terms we need to know. In this equation, X is called our independent variable. And Y is called our dependent variable. The value of Y depends on the value of X, and therefore Y is the dependent variable. It's dependent on the independent variable. The value of Y will change as the value of X changes. Writing Y as an expression using X is called expressing Y in terms of X. Okay, I'm going to say that one more time. Writing the equation in this way, Y equals X plus 10, is called expressing Y in terms of X because the value of X determines the value of Y. Let's create another linear equation. A rhombus has sides of length r centimeters. If the perimeter of the rhombus is p centimeters, express p in terms of r. So expressing p in terms of r means that r is the independent variable and p is the dependent variable. So you're going to start by saying that p is equal to something. Our problem tells us that p is equal to the perimeter of the rhombus. And if we want to express that in terms of r, we need to add all four sides of the rhombus together using the variable r. So that would give us 4r, right? r plus r plus r plus r is 4r. So because the perimeter of the rhombus is p centimeters, our linear equation is p equals 4r. Here's the first practice problem for you to try. Isaiah has H baseball cards. Miguel has 7 more cards than Isaiah. Part A, write an expression for the number of cards that Miguel has in terms of H. And Part B, if Miguel has K cards, express K in terms of H. Additionally, please label the independent and dependent variables for me. Press pause while you work. There are 4 more practice problems after this one. Okay, folks, here are your next 4 practice problems. Please read carefully to make sure that you're expressing the variables in the right relationship. Each problem will have a linear equation for the answer. In each answer, please also label the independent and dependent variables. Press pause while you work, and when you come back, we'll learn to use tables and graphs to represent our linear equations. Let's work through an example together where using a table or a graph can help us to represent our linear equation. The length of a rectangular picture frame is 5 inches longer than its width. Let W represent the width and L represent the length in inches. Since the length is 5 inches longer than the width, we know that length is width plus 5. Okay, so we can have many pairs of values for L and W that will make this equation true. If the width equals 1, then the length will equal 6. If the width equals 2, length will be 7, 3, and 8. A width of 4 gives us a length of 9, and so on and so forth. From this, we can see that the length is dependent on the width. So the width is the independent variable, and the length is the dependent variable. The data from our previous screen can be represented in a table, as I've shown here. The first row of the table shows the values of the independent variable, 1, 2, 3, 4, 5, and 6. The second row shows the value of our dependent variable, 6, 7, 8, 9, 10, and 11. Now we can use the data on the table to plot the ordered pairs, which would be 1, 6, 2, 7, 3, 8, 4, 9, 5, 10, and 6, 11 in a coordinate plane. So here's our coordinate plane. Let's plot our ordered pairs. So if our width is 1, our length is 1, 2, 3, 4, 5, 6. We'll put a dot right here. If our length is 2, our width is 7. A length of 3 gives us a width of 8. Length of 4, or width of 4 gives us a length of 9, 5, 10, 6, and 11. Sorry, my line's a little curved because my tick marks aren't exactly right. Please forgive me. Now we'll finish this up by connecting our dots to form a line, or at least as best I can with my not quite perfectly lined up dots. Okay. All linear equations are going to have a graph that is a line. So the graph of a linear equation contains all of the ordered pairs that make the equation true. For example, if we were to plot the point 2.5 by 7.5, it would be on this graph because that would make L equals W plus 5 true. We can see that the values make the equation true because if we look for 2.5 here, which would be, let me mark it with red here, 1, 2, 2.5, and we go up to our line, it should be roughly at 7.5 if we come back over to this here. So 1, 2, 3, 4, 5, 6, 7. Yep, it's at roughly 7.5. So for that value of W, our equation L equals W plus 5 is true. So the benefit of graphing our ordered pairs in a linear equation is to let us see all possible values that would make our equation true. Let's work through another example. Each can of paint contains 5 gallons of paint. Write an equation to show the relationship between the number of cans and the volume of paint. Okay, so if we're going to let V represent the volume and C represent the number of cans, we would write a linear equation that says V equals 5C. The reason that is our equation is because the volume of paint depends on the number of cans of paint. So C needs to be our independent variable, and V needs to be our dependent variable. Next, let's make a table to help us create the values that will be our ordered pairs. So if we have 1 can of paint, our volume is 5 gallons. 2 cans, 10 gallons. 3 cans, 15 gallons. 4, 20 gallons. And 5, 25 gallons. Because every V equals 5 times C. So now our ordered pairs will be 1, 5, 2, 10, 3, 15, 4, 20, and 5, 25. Let's go plot these ordered pairs on a coordinate plane. Notice as I'm drawing our coordinate plane that we use the horizontal axis for the independent variable, and the vertical axis is used for the dependent variable. So let's go ahead and graph these ordered pairs, or plot these ordered pairs. For 1 can of paint, we have 5 gallons. For 2 cans, we have 10. 3 gives us 15. 4, 20, and 5, 25. Now, we connect our points to draw a line, which goes through 0, which makes sense, because if you have 0 cans of paint, you have 0 gallons of paint. And now we can see that our line for V equals 5C contains all of our ordered pairs that will make the equation true. For example, if we had 4.5 cans of paint, that would give us about 22.5 gallons of paint. That makes sense, right? Because 4.5 times 5 is going to equal 22.5. Okay? All right, folks, we're going to finish up Chapter 8.2 with several problems that require you to use tables and then to plot points on a coordinate plane. It's going to take a few screens to post all these, and I'll talk you through each one before I ask you to work it on your own. Here's number 6. The width of a rectangular tank is 2 meters less than its length. If the length is p meters and the width is q meters, write an equation relating p and q. Then fill in the data points on this table and use that to plot the points on a coordinate plane. In question C, you're going to be asked to assess if a point makes sense in the situation you've been given. Press pause while you complete this problem, and problem 7 will be on the next screen. Here are problems 7 and 8. Please complete the tables and express the relationship between the two variables as an equation. Those directions apply to both problem 7 and problem 8. Please press pause while you work, and your final problem, number 9, will be on the next screen. And here is your final problem for Chapter 8.2. Use the data in the table below to plot points on a coordinate plane. Connect the points to form a line. Then, write an equation to show the relationship between the variables. Don't worry if you get stuck on any of these. We will definitely go over them together tomorrow. We'll also do more practice on writing linear equations. Thanks so much for your hard work, and I'll see you tomorrow.